Uh, Let us start with the session. I will quickly revise few concepts which I had discussed in the last session, and then I will start with today's session. Okay, so here we go. Uh, we are going to discuss operational amplifier. These are objectives. So yesterday we looked into some of the basics, and today we will see the application. Let me share something. Even today, we are going to take the attendance through the poll or the quiz. So do not write your number in chat section, right? Your attendance will be considered based on the answer that you give in the quiz, right? Fine. Now, in 1964, the first operational amplifier IC was designed with semiconductor by Fairchild Semiconductor, which is a manufacturer. The first integrated circuit of operational amplifier was designated 702. It was developed by Fairchild Semiconductor. This was later followed by 709, and eventually it became 741. And 741 is a very popular IC in the market. The internal diagram or internal structure of the operational amplifier is like this, where you can see that there are number of transistors. You can count it up to this. There are at least 20 transistors and many passive components being used, and this all the components including capacitors, resistors, as well as the transistor, all are embedded in a single uh, integrated circuit. We call this a chip, right? um, the This makes the pin diagram of 741, and physically it will look like this. A standard operational amplifier has two inputs. One input, which is termed positive, is called non-inverting, and the second, which is negative, is called inverting input. And there is an output. Okay, and in addition to this, there are there are two important terminals known as DC supply. You must power the operational amplifier with a DC supply, where there will be two supplies, plus and minus. So for example, if we use V is equal to 12, then we can use 12 volt, plus 12 volt, and minus 12 volt. The ideal operational amplifier has some of the desirable characteristics, like it has an infinite voltage gain, it has infinite bandwidth, it has infinite input impedance, and zero output impedance, right? A practical operational amplifier may approach this, but it may not fully achieve all these characteristics, right? Now the practical operational amplifier has a voltage as well as current limitations. Maximum output is limited between the supply voltage, that is plus VD, and minus VD. At the same time, the output current is limited by the power dissipation, the power which can be dissipated inside the integrated circuit. So for example, 741 has a short circuit current of 25 milliampere. That means at max the output can provide 25 milliampere current, and the power dissipation is 500 milliwatt, that is 0.5 watt. Okay, a block diagram of operational amplifier has three stages: differential amplifier input stage, voltage amplifier gain stage, and push pull amplifier output stage, right? The differential amplifier is the input stage, and it provides the amplification of the difference between the voltage. There is a second stage, another amplifier called voltage amplifier, and this further amplifies the signal, right? uh, whereas a push-pull amplifier is typically used in the output stage. So the output of the push-pull amplifier is actually given as the output, right? Uh, the term differential comes from the amplifier's ability to amplify difference between the two input signals. That means difference between the non-inverting terminal V plus and inverting terminal V minus, right? So there are two modes of operation: differential mode of operation and common mode of operation, right? In the differential mode, either one of the signal is applied to the input with the other input grounded, where so like this we have a single-ended differential mode where we provide input signal to only one of the input, whereas the other input is the grounded. Similarly here we have connected input to the plus terminal, non-inverting terminal, and inverting terminal is grounded, right? Whereas in the double-ended differential mode we provide two signals of opposite polarity and they are applied to the input, right? In the common mode, there is another mode of input signal that is called common mode. In the common mode, two signals of same phase, frequency and amplitude, that means same signal, we can say, it is provided to both the inputs. So we know that when both the inputs are same, then difference will be zero. That zero is amplified, so you will get zero output. This is mainly used for common mode rejection or the noise cancellation. Now, starting from a very important term, and that is negative feedback. So, negative feedback is the process whereby a portion of the output voltage, of an amplifier is returned to the input, and with a phase angle that opposes the input signal. That means if you have plus, then it will be inverted. Now, what does this mean? This is actually a sentence, but we need to understand this particular sentence in a very simplified manner, right? Because this sentence is basically written for um, a very professional people, right? Now, see what is the difference between. First of all, let us understand what inversion means. So yesterday also I had one question. Somebody asked me that what happens in the inverting terminal actually, and how it is different. Then so this is what happens in the inverting terminal, right? So let us say we are providing an original signal of 1 volt peak to the inverting terminal, right? And so there will be an internal inversion in the inverting terminal. What will happen? There will be an inversion, and because of that there will be 180-degree out of phase signal. So now we have um, inverted signal, right? The red one is the inverted signal. So the signal which was plus originally is now actually minus, right? This is called 180-degree out of phase, right? Now, and then it is amplified. So then the signal is amplified, so you get some output. Now let us understand that why we need the negative feedback at all, right? So far I was saying that okay, the gain is infinite, but having an infinite gain is not an advantage in operational amplifier, right? For example, let us take an example here. The inherent open loop gain of a typical operational amplifier is very, very high. This will be greater than we can 100K, right? 1 lakh, you can say. So, so an extremely small input will drive the output into saturation. What does this mean? For example, let us say that input voltage is very, very small of 1 millivolt, and the gain is 100,000. That is 1 lakh, right? So then the output is calculated as AOL. Now, how do you define the gain? The gain is actually the ratio of output voltage to the input voltage. So it tells you that how much voltage is being amplified, right? What is the amplification ratio here? So it is the output by input. And from this, what we understand that the output voltage is actually the ratio of input voltage and gain, right? That means if we have 1 millivolt here and we multiply it by 100, we will get higher output. So what happens in the operational amplifier? V output voltage is equal to 1 millivolt, that is 0.001, sorry, 1 millivolt 0.001 multiplied with 1 lakh, and that will give you 100 volt, right? But practically, even if you have, let us say, 1 millivolt and you want to get 100 volt, it is not possible to get the 100 volt output. Again, there is a query that why can't we get 100 volt output here? Let us see what happens. We can never reach 100 volt because there is a saturation limit, right? The saturation limit is decided by how much voltage you have applied to the operational amplifier. Let us say we have applied plus V maximum or plus V at a positive and minus V at the negative terminal. Then even if you have 1 millivolt, a very small signal here, the output will be saturated. The meaning of saturation is that no matter how much input you provide or how much gain you provide, the output will not change. It will remain um, as it is. For example, um, let us say the maximum speed of a car is 80 kilometer per hour, right? Then no matter how much acceleration you provide, even if you reach 80 and you are still providing acceleration, the car will never go beyond 80 kilometer per hour. Okay, because that is the maximum limit of a car, right? So similarly here in operational amplifier also, we have a maximum limit of output voltage, and that is decided by the positive and negative supply that we provide. And here, so here, if you provide 1 millivolt, let us say, which is positive, then the output will be plus V maximum. And if you provide minus 1 millivolt, it will be amplified by 1 lakh, and then you will get minus V maximum. So here, the output varies between positive maximum and the negative maximum. So we call it saturation. Now, this is not desirable because if our signal varies between positive maximum and the negative maximum, then the actual characteristics of entire signal is modified, right? Here we have, we can say DC. Here also we have a DC. So if it is sinusoidal, we are going to get a square wave, right? So what we do with negative feedback, the closed loop voltage gain can be reduced, okay, and it can be controlled. So with controlled gain, we can use the operational amplifier as a linear amplifier, right? Please try to understand, we are trying to control the voltage gain of, the voltage gain is what? V out upon V in. So we are trying to control the voltage gain of the operational amplifier circuit such that we can use operational amplifier as a linear amplifier. What is the meaning of linear amplifier? A linear amplifier means that if you provide a sine wave of a given phase angle and frequency, then you will get a sine wave of a given phase angle and frequency. The only difference is the output voltage will be greater than the input voltage. This is the meaning of linear amplifier. Okay. So what happens? Let us see. The meaning of negative feedback is this. We have certain input, and then what we do, we take a feedback from the output. and that output is divided by some value. We will see by example also that output is divided by some value, and then we give it back to the input. So here we have a summing amplifier, right? Input and the feedback, they are input is plus, feedback is minus. Minus means negative feedback. This is the meaning of negative feedback, that we have a minus signal, and that minus is actually coming from where? From the output. This is the meaning of feedback. And based on the input and the feedback, we have an error. That error will be multiplied by some kind of gain. As I said, it is going to be a gain of a closed loop, right? So then from this gain, we will get some output. Let us understand by a simple example. We have a missile with a tracking system, right? Now we always wonder that how that missile is able to change its path so that it can shoot down the target. The target is, in this case, the target is an aeroplane, a fighter plane, which we are targeting through a missile, right? Now, once the target is locked, once the target, what is target? It is fighter plane. Once the target is locked, then the missile will always target its position such that it can go to the fighter plane, right? Here we have an input. Input is what? It is going to be the target. It is going to be the fighter plane. And then if the target, if the fighter plane changes its path, the missile will also change its path according to the feedback. So we get some kind of feedback, right? And from that, we are able to track the fighter plane. This is the very simplified meaning of the feedback, right? So this kind of operation is only possible with the closed loop feedback. Now, let us understand by a simple example. Here we have an input voltage of 5.1, let us say, right? Now, uh, the uh, the feedback is, let us assume that feedback is 5.099, right? Feedback is 5.099. So the difference will be 5.1 minus 5.099. So your error signal is 1 millivolt. Error signal is 1 millivolt. Now the gain of the operational amplifier is, let us say, 10,000. Now if you multiply 1 millivolt with 10,000, the output will be, let us say, 10.198. There will be some error. So the output is 10.198, right? Now this is further divided by 2. If you divide 10.198 by 2, then you will get 5.099, which is again the feedback signal, right? So this way we are getting input voltage of 5.1 to 10.198. This process is called amplification, right? Here the gain, overall gain is 2. You can see that input voltage is 5.1, output voltage is nearly 10.2, we can say, right? This process is called amplification of the signal. Now, the closed loop voltage gain is the voltage gain of an amplifier with external feedback. We have an external feedback here, right? And the closed loop voltage gain is determined by the external component values, and it can be controlled by them, right? So based on the type of the input, the amplifiers, linear amplifiers that we are talking about, right, they are divided into a non-inverting amplifier and inverting amplifier. We are here today, we are going to discuss about non-inverting and inverting, both types of amplifiers, right? Now the input signal in the non-inverting amplifier, the input signal is applied to the non-inverting or the plus input. You can see that, right? And the output is applied so that it is fed back to the inverting terminal through the feedback circuit. So here we have a feedback circuit. What kind of feedback circuit is that? It is a voltage divider circuit, right? So that we have an output voltage between V out and the ground, and then we have a voltage divider. So we are going to get some output out of the total output to the input again, and that is given to the inverting terminal, right? This is how the non-inverting amplifier is connected. So if you see the VF, the value of VF is determined by the feedback circuit. So it is going to be Ri, because this is where we are tapping the output between this and ground. So what is the resistance here? It is Ri divided by the total resistance. I have done nothing but simply applied the voltage divider rule. So the output voltage is divided based on the value of Ri, and that is your feedback voltage, right? So now we have a feedback voltage value, and we also have input voltage value, right? So what happens? The difference of the input voltage V in and the feedback voltage Vf is the differential input, right? As you know, the input to the op-amp is always differential, right? So the differential input is given by V in minus Vf, just like what we did in the last slide, 5.1 minus 5.099. Now the differential voltage is amplified by the open loop voltage gain, right? Here we have open loop voltage gain here, right? So V out is equal to open loop voltage gain into V in minus Vf, V in minus Vf, right? Okay. Now let us say that Ri upon Rf plus Ri, what we discussed in the last slide. Let us say the Ri by Rf plus Ri, because it is voltage divider. So voltage divider is also known as attenuation circuit. Okay. The meaning of attenuation is it's just the opposite of amplification. In amplification, we amplify the signal, increase the amplitude of the signal. In attenuation, we attenuate, that means we decrease the value of the signal. So here we are actually decreasing the signal, and that's why we call it attenuation, right? So the B is called attenuation, and it is determined by Ri upon Rf plus Ri. For example, if Ri is 1 kilo ohm and Rf is also 1 kilo ohm, then we have 1 upon 1 plus 1, and that is equal to 0.5, right? So it is actually decreasing, it is less than 1. Okay, and if the gain is less than 1, then it is called attenuation, right? So now Vf is equal to B into V out. Where do we get it? From the last slide. Now if you substitute BV out for Vf, right, from here we have Vf, and Vf is equal to BV out. So if you put BV out in that earlier equation, then we have V out is equal to AOL into V in minus VV out. And if you simplify the above equation, then we get V out upon V in is equal to AOL upon 1 plus AOL into B, right? But AOL into B, because as we know, AOL is actually very high, like 1 lakh or higher. So the multiplication of AOL and B is much greater than 1. So we can neglect the 1 here. So we get AOL upon AOL into B. AOL and AOL will be cancelled, and we have 1 upon B here, right? That means the closed loop gain, sorry. So closed loop gain of the amplifier B out upon V in is equal to 1 upon B, and that is Ri plus Rf upon Ri, right? And that is given by 1 plus Rf upon Ri, right? That means the closed loop gain of non-inverting amplifier is determined by 1 plus Rf upon Ri. Okay. Now let us see, we are going to apply the closed loop voltage gain of the amplifier in the figure. So we have to determine what will be the closed loop voltage gain here, right? You know the you know the equation, you know these values. Now just um, I have, sorry. Now I'm going to, I hope you can listen to me, right? I'm going to copy and paste, I'm going to copy and paste this link in the chat section. Okay, you have to, now you need to answer this. Okay, sorry for this setting issues. There are some setting issues here. Okay, um, the link that I have given is actually, presently it is not active, right? So I'm trying to enable that link. So please try to open the link that I have given in the, okay, I'm getting some responses here. Okay, okay, now the link is open, right? And you need to calculate from the given value and find out the closed loop voltage gain. Okay, you know the value of RF, you know the value of RI, and then you have to calculate the voltage gain of the circuit. You just answer. Okay, we have 2 to 3 minutes to answer this. Again, I'm telling you, all students have to go through the link and give the answer. So far, I have received answer from 12 to 13 students. Okay, those who are trying to answer, they are also getting the answer. So this quiz will continue for 1 more minute, and then I will move on to the session again. Okay, now I will go back to the session, right? Here, let us again discuss the modified form of the operational amplifier circuit, or the non-inverting terminal circuit, and that is voltage follower, right? The voltage follower is actually the special case of non-inverting amplifier, where the output voltage, the enter output voltage, is fed back to the inverting input by a very straight connection like this, right? So in the previous circuit, if you see the RF, or the feedback, okay, the feedback resistance is 0 because we are shorting this, right? So if the feedback resistance RF is 0, then A closed loop is equal to 1 plus 0, so 1. That means closed loop gain is 1. What does this mean? Gain is 1 means whatever is the input, same will be the output, right? So this way, the closed loop gain of voltage follower is 1. So then why do we need it, right? If we know that we are using linear amplifier and we want to amplify the signal, right? If we are not amplifying the signal and we are keeping as it is, right, then what is the purpose? So the purpose of using a voltage follower is that you are connecting a weak signal, a signal, to the operational amplifier. Now the operational amplifier has a very high input impedance, right? So that means this, the weak signal is driving very high input impedance. So the current requirement from the signal will be almost 0. If the current is nearly 0, then the power required will be 0. If the power required will be 0, then there will be no burden on the input signal, right? It is like when we are speaking something, the signal may be very weak comparatively, and then uh, we put the same signal through some kind of amplifier. Okay, now the high input impedance will reduce the burden on the source, and at the same time there is a low output. So that means if your input signal is not able to provide, let us say, 10 milliampere, because it is very weak. Consider an example of my heartbeat. So the my heartbeat is very weak signal, so it may not be able to provide 10 milliampere to the output, right? So if that is not possible, then we use the voltage follower circuit, right? So it's what does it do? It simply increases the current output. Output of voltage is same, right, as the input, but the current is increased, and the current is increased, so the overall power output increases. That's why we call it a buffer amplifier, right? It is only used for buffer. Okay, if anybody has any question, we have less than 2 minutes. If anybody has any question,